Let's go to an example here. And I don't want you to see the answers. I erase it. Da, 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 da. Don't look. A particle moves in a straight line so that its velocity, v in meter per second at time t, is given by v equals c squared minus 4t. Find an expression for the acceleration. As we said before, acceleration is the first derivative of velocity with respect to time. So power goes down, decreases by 1. And the t here evaporates, so it will be 2t minus 4. Remember to put it in brackets and write the units of measuring, which is meter per second squared. Here is another worked example. A car moves in a straight line so that its velocity v meter per second at time t is given by 5t squared minus t cubed for t less than 4 seconds and more than 0 seconds. Find its acceleration when t equals 2. In this case, he needs to substitute after finding the acceleration. First of all, find the acceleration as a first derivative of velocity with respect to time. Power goes down, it will be, decreases by 1, it will be 10t. Power goes down, decreases by 1, it will be minus 3t squared. This is acceleration at any time, but at specific time when t equals 2, acceleration is 10 brackets minus 3 brackets squared. I always advise to put empty brackets and then put 2's in the brackets. So how to calculate this 20 minus 12, it will be 8. 8 what? 8 meter per second squared. Da-da-da. So simple, so easy. In the first video, we went slowly because this is a new concept, but now we can go fast. Another example. Don't see, I erase. I don't want you to see the answers. No. Let's read. A particle moves in a straight line so that its displacement s at time t is t less than or equal to 10 seconds and more than or equal to 0. So 0 and 10 are inclusive, is given by this formula as a cubic function. Sketch the shape of the velocity time graph for the particle, hence the maximum speed of the particle. So this is displacement, and he wants to sketch the velocity time graph. So we have to find first velocity as a formula. Of course, a cubic function, when you differentiate, power goes down, decreases by 1, expect that the velocity will be a quadratic function. Quadratic function, how to sketch quadratic function? It's a parabola. It could be a smiling parabola, it could be a sad parabola. But in this case, because it will be positive t squared, so it's a smiling parabola. So now, v equals ds by dt. Let's say power goes down, decreases by 1. 3 times third is 1, 1t squared. Minus power goes down, decreases by 1, minus 12t plus 15, and the t will evaporate. Now, to sketch this, we'll draw x and y axes using our ruler. Of course, time will not start from negative because time can never be negative, right? But the velocity can be positive and can be negative. In order to sketch it, I need to find the start and the end of this strip. Here is 0, and here is time axis. Of course, time axis is always horizontal. Time axis measures time in seconds, and velocity axis, which is the y-axis, measures velocity in meter per second. And we have to find first at t equals 0. Of course, t equals 0 will give you the y-intercept, which is the v-axis intercept. It is crystal clear. It's 15. V equals 0 minus 0 plus 15. So v equals 15. So the point of intersection with y-axis is here at 15. And you will draw a parabola, but we need to know also what is the value at the last point, it means he said that t-axis starts from 0, ends at 10. So at 10 seconds, we need to find the value of the velocity. At t equals 10, just substitute. The velocity will be bracket square minus 12 brackets plus 15, and substitute tens. Let's calculate. 100 minus 120 plus 15 equals -5. So there is a value here which is -5. Of course, we're trying to be reasonable. Yes, it is not to scale, but the distance on y-axis 15 should be 3 times the distance, which is 5. Now, how to draw the parabola, which is smiling? It will go like that. Da-da-da-da. It's a parabola, and cuts y-axis at 0 and 15, and it ends at t equals 10 at velocity is -5. This is a perfect sketch, and you will take the full mark when you draw. Hence, find the maximum speed of the particle. The word maximum in differentiation is a clue. The word maximum, minimum, stationary point, turning point. The maximum speed of the particle at, this is part B. Maximum speed, it means maximum velocity, occurs at dv by dt equals 0. dv by dt equals 0, it means gradient of the tangent of the curve is 0. Gradient of the tangent of the curve is 0. So here we have the velocity, which is, we got it already. And now we need to find dv by dt. Of course, it is acceleration. Yes, it means acceleration is 0. So power goes down, v by dt. Power goes down, decreases by 1. We have here v, power goes down, it will be 2t, and minus 12t, it will be minus 12. Put this, put it in a box always. And now we equate it to 0. 2t minus 12 equals 0. Cross the bridge, change the sign, so t will be 6. So at t equals 6 seconds, we will have maximum velocity. Okay, when you look at this graph, where is the part? Of course, we know that gradient of the tangent to the curve, especially for the quadratic functions, it will be always 0 at the vertex. But for cubic function, we don't call it vertex, okay? So this vertex is at 6. Yes, but velocity will be how much? We simply can calculate it, right? So this point is 6 on the x-axis, 6 seconds. T is 6 seconds on the x-axis. You can substitute just to find it. He wants to find the maximum speed, you just substitute in Vmax. So now substitute in the formula of V, which we found it now. V is bracket square minus 12 brackets plus 15, and you just substitute inside each bracket with 6 seconds. And calculate it, of course, referring to our sketch, expect the velocity to be negative. Negative means in opposite direction. Don't panic. When the velocity is negative, it means you return and you are moving in opposite direction. So here now we calculate it, and it will be negative 21 meters per second. If he asks about velocity, say it's negative. If he speaks about speed, remember that speed is the modulus or the absolute value of velocity. We just mentioned it is 21 meters per second without putting a negative sign. Okay? And there is also another point on the diagram when t equals 0. I can see in my sketch that the highest point on the positive v-axis is 15. Okay? So now we can write that at v, when t equals 0, velocity will be bracket square minus 12 brackets plus 15. Of course, we found it already. It is 0, 0. So it will be 15 meters per second. This 15 meters per second occurred at the beginning. And also, why don't we substitute and get it at 10? We did it before. At 10, it is -5. So we have here 3 values for velocity. One of them is -5. One of them is -21, which is 21 after finding the speed. And one is 15. So which one is the maximum speed? This one is the winner. Yay! Thank you, dears. And we'll meet in the next video to complete about acceleration as a first derivative of velocity with respect to time, and then we'll explain integration too. Bye-bye.